What I'm after here is the ability to reuse my modules in all my projects with absolutely zero modification needed. If you're interested in that dream, subscribe, hit the bell and keep watching. There seem to be many people missing the whole point of my solution to many problems. I even got claims of technical difficulties which would cause serious performance costs, leading to reasonable justification of dropping OOP principles. What you saw earlier was a prototype, just to give you the general overview of the solution. In this video, I showcase my actual implementation of the solution, fixing any probable performance costs, improving the workflow. So let's get started. I've got 3 custom nodes: sender, receiver, and receiver base. Using some editor scripting trick, I managed to make the sender inspector look different between the instances and the actual scene. So when you navigate to the scene itself, you get the ability to modify the list of valid sender types, and it will update the whole system immediately. When you add sender as a node, however, the modification ability is gone and you can use it like a drop-down enum list. However, there is no enum here. It's a dynamic list you can update whenever needed. On the receiver side, I simply add the receiver base node. If I wanna make it sensitive to, let's say, fire and water types, I just add 2 receivers as the children. These are just helper nodes to make the inspector interface look nicer. They'll be freed when the game runs. Inside the receiver base, you also have the ability to pack or unpack the receivers. This way, you can make them go away even in the editor itself. I've also added cool warning notifications, killing any chance of misusing the system. So if you rename stuff or move them in the hierarchy in ways you are not supposed to, or if you have a typo, it gives you appropriate warning. I'm not gonna get into how the system is working internally. It's the subject of other videos. However, this is how the designer is supposed to use the system. Let's make the player sensitive to water and fire types, calling swim and dive functions when a contact happens. We also need to add the sender to the zone scene. Now I can simply connect the sender send function to any signal in absolutely any system, and it will work, placing a water and a fire zone in the level. Let's run the game. And the system is working perfectly. But this video isn't only about how awesome the sender-receiver system is. It's about how maintaining OOP principles helps you in the long run. One may argue that I've spent too much time engineering something not needed that much. He may argue that I've wasted my time and it would be wiser if I spend that time on actual games. I believe that this is a pretty narrow-minded and short-sighted point of view, because by creating this system, I've solved the many problems not only in the current project, but in all my future project. The system works completely independent of the game using it, hence my effort here is gonna help me forever and ever. When you start working on your properly structured systems, of course you get less projects done. However, when your module library gets big enough, your production speed and your project scalability increases dramatically. OOP principles are not some random philosophical thoughts of old gurus who have lost their touch with practical programming on the last days of their lives. Looking at Godot documentation best practices section, you see that OOP principles must be maintained under all circumstances, whenever possible. Back to the receivers, you may wonder why I'm calling the root node functions by name using a callable. Wouldn't it be better if I use signals so that the receiver could be connected to all sorts of functions in the whole hierarchy? Well, no. By setting it up in this way, I'm forcing the designer to structure the hierarchy in a specific way, maintaining reusability even more. Watch the next tutorial to see what I mean. Thank you.